In this video, we will describe the supply function. So for this, we will again have three forms of description of a supply function. We could write down a mathematical formula, for supply function. We could have data in the form of a table, data in the form of a table with price and quantity pairs, and we will assume the relationship between the price and quantity to have some particular nature. That will also be a perfect description of supply function. And then the third one, we could draw a graph, or we might be given a graph of a supply function. But we know the convention in economics is that when we say graph of supply, we would actually be drawing graph of an inverse supply function. This is our convention. We draw graph of an inverse supply function. So now I will describe when we say mathematical formula for a supply function. This supply function is a relationship between the price and the quantity. So supply function is a relationship between price and quantity. I will use notation P for price, Q for quantity, and then we will consider an example. Let's say it is given that Q is equal to minus 2 plus P. So if I am assigned a price, I will be able to figure out the quantity. And let's now, for this example, take the price to be in the unit of dollars per pound, which means quantity is in unit of pounds. So given this supply function, we could figure out the quantity firms are willing and able to sell at any given price. So take P to be $8 per pound, then the quantity firms are willing and able to sell is minus 2 plus 8, 6 pounds. We could also see from this function, this relationship, that the firms would not be selling any quantity for prices $2 per pound and below. So when price is $2 per pound, firms are willing to sell 0 units. The only situation where the firms will be selling positive quantity is when price is above $2. So I already have one example. Price is $8 per pound. We know the quantity. Price is $2 per pound. Then the quantity is 0. This is what I have already described. So that's the relationship described by a mathematical formula of a supply function. As we have noticed in this form, the price is the independent variable and quantity is the dependent variable. So now we will look at data which describes price and quantity pairs observed in a market. So let's say price is 0, firm sell 0 units, price goes up to $2 per pound, quantity goes to 4 pounds. So let me write down the units, pound for the quantity, dollars per pound for the price. Price goes to $4, quantity goes up to 8 units, price is $10, quantity is 20 units. So we can see the relationship between price and quantity is positive. Price goes up, firms want to sell more. Given this data and the assumption that the relationship between price and quantity is linear, one could actually draw a graph for this data, pertaining to this data, as well as we could write down a mathematical formula for the supply function. So before I go to write down a supply function formula, I'll go to the third step, which is description of supply via a graph. And as we have noticed earlier, we will be drawing the graph of an inverse supply function. So I will have quantity on the horizontal, price on the vertical. This time the unit of price is dollars per pound, quantity is in pounds. And so if we want to draw the graph for the data given here, we could see when price is $2, quantity is 4, price is $4, quantity is 8. So we have a point here, a point here, and when price is 0, quantity is 0. So this is a relationship which looks something like this. So this should be a straight line. And now, so this is the graph of inverse supply function. Now I can write down a mathematical formula for this graph, for this straight line. We could see the slope of this straight line is, so I have price changing from 2 to 4. It leads to changes in quantity from 4 to 8. So minus 2 in the numerator, minus 4 in the denominator, 1 over 2.5. So the slope of the straight line is 0.5, and then the vertical intercept is 0, which means the formula for the inverse supply function is 0.5, P equal to 0.5. So that's the inverse supply function. And then, so 2 points to mention. First, if I am given a graph, I can create a table of price quantity pairs which are relevant for the application at hand, or I can also write down a mathematical formula if the graph is well behaved. If I am given the inverse supply function, again I can draw the graph as well as I can prepare a table. If we have the table given to us and we assume the relationship between price and quantity to be linear, we can draw a graph. Graph we can draw independent of whether we have a linear relationship assumption or not, but with linear relationship we can also write down a mathematical formula. So Now let's look at a situation where we are assigned a supply function and we want to obtain the inverse supply function, because that is what we'll draw as our graph. So let's start with the first one, which was given to us, q equal to minus 2 plus p. So I need price on the left hand side, quantity on the right hand side. So one way to do, I need minus q, I need q to go to the right, so I subtract minus q both sides. So I have 0 here, minus 2 plus p minus q. Now I want p on the left hand side, so minus p from both sides. So I have negative p here, negative 2, negative q. And now you could see we have negative sign on each term on both sides. So maybe we multiply both sides by negative 1 to obtain p equal to 2 plus q. So this is the inverse supply function. And maybe I will draw a graph for the inverse supply function as well. So I have price on the vertical, quantity on the horizontal. Dollars per pound is the unit for the price, quantity is in pounds. So we have vertical intercept 2, slope is 1, so that's a straight line. And supply function has positive slope, which is what we observe here. So if I am given a supply function, we can find out the inverse supply function. I will go back to the second example where we found the inverse supply function, p equal to 0.5 q. Given this, I want to find out the supply function. So let's do that too. Inverse supply function. Given to us is p equal to 0.5 q, and I want to find out the supply function. So we could divide both sides by 0.5 to obtain p over 0.5 is 2p equal to q, and now we could flip the two sides. The equality sign would be maintained to write this expression as q equal to 2p. So this will be our supply function. So again we have both the supply as well as inverse supply function. Any one of it is given to us, we can find the other. And so here I will like to assign an example for you to work as an exercise. So let's say the supply function is given to be minus 4 plus 2p. This is the supply function. And so I will like you to find the inverse supply function. In this case, this I leave it as an exercise, and this is a good point to stop.